Hi, this is for the virtual collaborative discussion for Chapter 5, and we are from the Group 3 and we are assigned to present the tutorial question for question number 10. And I'll pass the floor to Putri Balkis, and she's going to explain the schematic diagram of heat exchanger. Putri, please.
Okay, for the schematic diagram, the heat exchanger is to heat water from 25 Celsius to 60 Celsius. The mass flow rate is 0.2 kJ per second. The heating is to be accomplished by geothermal water. The mass flow rate is 0.3 kJ per second at 140 Celsius.
Okay, for the part B is the functions of the heat exchanger. One of the functions of the heat exchanger is to transfer heat between two different fluids. The fluids are separated by a solid wall to prevent them from mixing together. The heat exchanger can be used in both cooling and heating processes. Next, the heat flow is transferred from the hot fluid to the colder fluid. One of the fluid will flow in the inner pipe, while another will flow in the annular space outside the inner pipe. Thank you.
Applications of heat exchanger in real life. For shell and tube heat exchangers, it can be used in oil refining, removal of processed heat and feed water preheating, oil cooling and preheating process, cooling of turbine, compressor and engine. As for double pipe heat exchanger, it can be used in industrial cooling process and small heat transfer area requirements. Heat exchanger can be used in various industries as it is high performance, high transfer rate and compact volume. So next we'll move forward to our tutorial question that will be explained by Jabir.
Alright, so for tutorial question 10, the assumptions that are made is control volume, open system, steady flow process, there is no change in kinetic and potential energy, heat loss to surrounding is negligible, and finally the heat loss from geothermal water is fully absorbed by water flowing in the pipe.
The overall energy balance of the heat exchanger, as you can see from the equation 1, the rate of change energy entering the system minus the rate of change energy leaving the system is equal to change in energy of the system. And since the energy entering the control volume is equal to the amount of energy leaving the control volume, thus the change in energy of system is equal to 0, as you can see from the equation 2. And then rearrange the equation 2 into equation 3 and you get. And since the heat from the geothermal water is flowed into the water in the tube, so Q in present. And it's assumed the system is stationary, so the change in kinetic energy is equal to change in potential energy is equal to 0. And for mass flow rate, the unit is kilogram per second, enthalpy is kilojoule per second, and Q in is equal to kilojoule per second.
Okay, for the energy component present, Q in represents heat flows from geothermal water to water. Thus, rate of heat flow is present. For the second one, which is the mass flow rate multiplied with enthalpy in, represents rate of energy transfer by mass into the system is present in both systems. Okay, for the next part is the mass flow rate multiplied with the enthalpy out, which is the rate of energy transfer by mass out of the system represents in both systems. Okay, there is no change in kinetic energy and enthalpy energy because it is assumed that the system is slow in velocity and small change in elevations. Thus, no work done on or by the system.
And this will be the working step for solving question number 10. And for part A is to calculate the rate of heat transfer in the heat exchanger Q. And Q in, which is the rate of heat flow into the system, is equals to mass multiplied by the enthalpy out minus the enthalpy in, which is the equation 5. Then the equation 5 can be modified to equation 6 by substituting H equals to Cp dt, where Cp is the specific heat capacity of the water, and then we can to form equation 6. Then after substituting the value from the questions, then we will get the value of Q is equals to 29.26 kilojoule per second, and multiplied by the conversion factor, it will be 29.26 kilowatt. Thank you.
Okay, since there are no other component than energy, we can say that heat loss of the geothermal water is equal to the heat gain of the water. And then we put a negative sign to show that the heat is lost from the geothermal water to the water. Therefore, since Q equals to mCp delta T, we can rearrange the equation to get T2, which is the active temperature of geothermal water. And then when we substitute and put in the values for the equation, our exit temperature will be 117.4, which is the T2. Therefore, that is all from us. Thank you.